Okay, looking at the last three application problems from 14.4. On problem 13, it talks about Paul driving north and Cynthia driving west from a house here. Let me get this right angle. I got the rate for Paul is 9 miles per hour slower than Cynthia, and they both travel for 1 hour. So here we get the distance. So Paul's distance is here, Cynthia's distance is here, and then it does tell us that they're 85 miles apart. So that's from here to here. And so we get all the pieces of our right triangle. So at this point, I could multiply all that out and use factoring or the quadratic formula, but instead I chose to put it into Desmos. And when I graph this, I get this, I have to adjust my window. It's again tricky to adjust your window, but you have to play around with it a bit. And you get this parabola here from the left side of the equation, and from the right side you get the horizontal line. And what you'll find out is that they intersect at x equals 64.44. Well, that would represent Cynthia's speed of 64.44 miles per hour. Okay, so this would be Cynthia's speed. Okay. And if they asked for Paul's, you'd have to subtract 9. Now, problem 14, it's not that tough of a problem compared to the other ones, I think, but maybe you'll find it difficult. It does say that the cost is represented by 44 plus 55x, where X represents cameras and X is representing cameras here also, okay? Sold and produced. So X either represents sold cameras or produced cameras. So it tells us the revenue is created by this formula. Well, if we want the break-even point, we can just set those two formulas equal to each other. Manipulating that, we get this in standard form, and we can factor it. And we actually find out that there's 2 break-even points, 4 cameras or 11 cameras. And it says to separate our answers with a comma. So we could say X is equal to 4, 11. And then this last one here, it talks about a brat business that sells brats for $3. And when they sell them for $3, they sell 2,000 brats. And so they would have a revenue of 6,000. But after a little studying, they realized that if they increase the brats by 25 cents, so 1 increase, we put 1 in for X, 2 increases, we put 2. Okay, so if you think about 2 increases, a brat would be $3.50. Okay, but every time they have a price increase, what happens is they sell 50 fewer brats. Okay, so think about what happens after they had 2 price increases. They would sell 50 times 2, 100. They sell 1,900 brats. So, but how does this work out then? Is it ever better revenue to sell less brats? And what you find out is that if we put this into Desmos for y1, we end up getting this parabola here. And what this parabola represents is that at this high point right here, if we did 14 increases of price, we would reach our max revenue. Now our max revenue occurs at 14,850. So does this mean to sell the brats at $14? No, that means we have 14 increases in price. So if we put the 14 in here, okay, what we find out is that it's an increase of $3.50. So we would have 3 plus 3.50, and we find out that we should sell our brats at $6.50. If we sold our brats at $6.50, our revenue would be $8,450. Now, also in this question, it says, is revenue the same as profit? Remember, this does not represent profit. Okay, it's just the amount of money that's brought in. we also have to subtract, we'd have to take this 8,450 minus our cost to equal our profit. Okay. Well, that wraps up 14.4. I hope that you found some of this useful. Remember, there's various ways to solve these: graphing, quadratic formula, factoring, and the setup is going to be the hardest part with these. Thanks.